This video is for educational purpose only. No copyright infringement. This copyright belongs to its rightful owner. Credit goes to respective video, music composers and singers. Hello friends, I'm Dr. Vanita Raut, Assistant Professor, Department of Physics, Dr. Patangrao Kadam, Mahavidyalaya, Ramanandanagar. Today we are going to discuss one of the topic from paper number 14, Solid State Physics, Symmetry Elements of Cube. The outline of presentation is what is symmetry operation. Then we are going to discuss the various symmetry elements of a cube, in which we are going to discuss three elements as rotational axis, mirror planes and inversion centers. So firstly we must know what is symmetry operation. A symmetry operation is an operation which can be performed either physically or imaginarily, which causes no change in the appearance of the crystal. It means that the crystal remains in its original condition, in its original appearance. The symmetry operation leaves crystal and environment unchanged. This is because crystal symmetry, or when we consider crystal, it is a definite order arrangement of faces and edges of the crystal. And here we are going to discuss now three types of symmetries, as the crystal possesses the three type of symmetries accordingly as rotation, reflection and inversion. These symmetries can be named as rotational axis, or it is also called as the axis of symmetry. Second is plane of symmetry, which is also called as a mirror planes, and third one is the center of symmetry, which is also called as an inversion center. So all these three operations we are going to discuss in case of a cube. So let us see the different things about the cube. Now when we consider cube, this figure shows cube, that is, it is having three main important part, as first one is the faces, second one is the vertex and third one is the edge. As we know, the cube is having total 6 faces and it is having total 12 edges. Now edge is the part where the two faces they meets. Two faces where they meets, they forms a line, and that line is called as an edge of the cube, and cube is having total 12 edges. Again, the corners of the cubes, they are also called as the vertices. Since cube is having total 8 corners, therefore it is having 8 vertices. So in case of cube, one has to keep in mind that it is having 6 faces, 12 edges and 8 vertices. Why it is important? Because when we are going to discuss the symmetry elements, these three things are very important so as to understand the symmetry operations. Firstly, we are going to discuss first type of symmetry, that is nothing but the rotational axis, which is also called as the axis of symmetry. Now what is axis of symmetry? Definitely it is a axis, or which is also called as an imaginary line which passes through the crystal. Now around this imaginary line, when the crystal is rotated, then it presents the same appearance more than once in one complete revolution, which is also called as a in a rotation through 360 degree. So in this way, crystal achieve the congruence. Congruence means self-coincident position. Here, let us see the examples. As suppose the crystal achieves congruence if it is repeated n times in rotating through an angle of 360 degree divided by n around an imaginary axis. Then the concern axis is also called as a having n-fold axis, where n is the order of axis, or in other words one can say that n is number of times how many times the crystal will achieve the congruence or self coincident position in one rotation of 360 degree. For example, uh, let us see the rotational axis in case of cube. Now the first one diagram, it shows that if we rotate cube about a vertical axis which is passing through the center of two opposite parallel faces, then it is observed that in one complete rotation of 360 degree we get four positions. Means after each 90-degree rotation we get, or the cube is bring in its self coincident position, which is also called as a congruent position. Hence this axis of rotation is also called as the axis of symmetry, and there are total four congruent position in one complete rotation. Hence the concerned axis is also called as a tetrad axis or fourfold axis of symmetry. So if we observe the table, one can see that tetrad axis, the angle of rotation for the self coincidence is again 90 degree. Tetrad axis, it passes through the center of two opposite faces. Since cube is having total 6 faces, if we consider the opposite pairs, then we have total 3 opposite pairs. Hence cube is having 3 tetrad axis, and diamond is the symbol of this tetrad axis. Now if we observe the second figure, then it shows that here we have considered the axis which is along the body diagonal, or in other words one can say that the axis is passing through two opposite vertices, and when the crystal is rotated through around this axis, then after each rotation of 120 degree the crystal will achieve the congruent position or self coincident position. Hence in one complete rotation of 360 degree the crystal achieve congruence 3 times. Hence this axis is called as a triad axis. In other words, it is also called as a threefold axis. So it shows that threefold axis, since it is passing through the two opposite vertices. Cube is having total 8 vertices. If we consider opposite vertices, then there are 4 pairs of opposite vertices. Hence we have here triad axis for a cube as 4, because there are 8 vertices, so pair of opposite vertices are 4. Hence cube is having 4 triad axis. Again this triad axis is shown by a triangular shape, or the symbol for it is shown over here. Next to that is the diad axis. Now in case of diad axis, this diad axis through a cube, it passes through midpoints of opposite edges. Again one important thing here is that if we consider axis which is passing through the midpoints of two opposite edges, then it is observed that if the crystal is rotated, then in one complete rotation of 360 degree the crystal will achieve a congruence 2 times. Means after each rotation of 180 degree the crystal is in its self coincident position, and since there are total 12 edges to the cube. Hence, there are total 6 opposite parallel edges. Okay. Therefore, cube is having total 6 diad axes which are passing through midpoints of opposite edges. These diad axes, they are also called as having two-fold symmetry or two-fold axis, which is shown by a symbol of oval. So, in one and all, if we consider rotational axis for a cube, then it is observed that cube is having 3 tetrad axes, 4 triad axis and 6 diad axis. So in addition to all these, the cube is having 13 axes of symmetry. Now in nature, apart from cube, there are number of crystals which also shows different type of symmetry. For example, if we consider a hexagonal type of crystal, then it is having hexadaxis. What it means? It means that after each rotation of 60 degree, the concerned crystal will shows the congruence and it achieves the self-congruent position. Means for every 60 degree rotation, the crystal is in its self-congruent position. Again, one important thing here one has to note is for all the crystal which are naturally grown, they don't possess five-fold symmetry. So all this is about the rotational axis of symmetry. Next to that, we are going to consider the mirror planes. Now we know that mirror planes, when we are going to discuss these mirror planes are the imaginary planes which passes through the cube. We know that the cube is bilaterally symmetrical, and in the cube there are imaginary planes which bisects cube or which makes two equal halves of the cube, and these two equal halves, they are exact mirror image of each other. It means that the cube can be divided into two equal halves, and out of that two equal halves, if one half we take and place it on the mirror, then it is observed that the other half is nothing but image which is in the mirror. So if we cut the cube along the plane and place it on the mirror, then the image will definitely reproduce the other half of the crystal, and hence such a plane is called as a plane of symmetry. Since these mirror planes, these are designated by a letter small m. As we have discussed, in case of rotational symmetry, the figures which we get, they are self-coincident figures which are also called as a congruent figures. But in case of plane of symmetry, we get a second kind of figures. They are called as a enantiomorphous figures. Enantiomorphous figures means which are mirror images of each other. In case of plane of symmetry, the reflection of the crystal is through plane. Let us see the different plane. Mirror planes in case of cube. Now here total 9 planes of symmetry a cube shows. Initially the upper one they have shown, these are 3 planes of symmetry, and the remaining below, they are the diagonal plane of symmetry. The cube is having total 3 plane of symmetry, and since cube is having total 6 diagonals, 6 diagonals which are formed due to opposite parallel edges. Since cube is having total 12 edges, and hence pair of opposite parallel edges will be 6, and hence the cube is having 6 diagonal plane of symmetry. What it means? It means that if we cut the cube along this diagonal plane, and if we place one half of this diagonal plane on the mirror, then image in the mirror will reproduce the other half. So in and all, the cube is having total 3 plane of symmetry and total 6 diagonal plane of symmetry. So total planes of symmetry are 9. And as I have told you that the figures produced by this plane of symmetry, they're not congruent figures, but they are having a different second kind of operation, which are nothing but the mirror images of each other, or in other words, they are n endomorphous figures. Now, next to this, we are going to discuss the center of symmetry, which is shown by the cube. Now, the center of symmetry, a crystal always possesses a inversion center most of the time. In case of cube, it is definitely possess a center of inversion, and it lies at the body center of the cube. So, it is an imaginary point in the crystal that any line drawn through it intersects the surface of crystal at equal distance on the either side. Means one can say that if uh, if we consider center of symmetry, then which is also called as center of inversion, then it is a point in the crystal or the body that if a line is drawn from any point on the crystal through this center point and extended an equal distance on either side of this center point, then definitely or surely it will meet at an identical point. Means for the point A we get A dash, for the point C we get C dash, for the point B we get B dash. So center of symmetry or center of inversion is reflection through a point. So for a cube, it is having single inversion center which lies at the body center position. And again, the figures which we get in the center of symmetry are the mirror images. Again, this mirror images is through a point. So the kind of figures which we get here in case of inversion center are the n endomorphous figures. So cube is having one inversion center. So in addition, if we add all these symmetry elements of a cube, so we can say like that cube is having total 23 symmetry elements, of which the total number of planes, axis and center of symmetries possessed by the cube are here, as the cube possesses total 13 rotational axis of symmetry, total 9 mirror planes and 1 center of inversion. If we add all these symmetry elements, then we get total 23 symmetry elements of the cube. Thank you.